welcome to Easy Mathematics and a new video for the MIT Integration Bee 2020. These three integrals are from the qualifier round, and if you want to try this by yourself, for the first integral I have the hint, think of substitution. For the second one, think of adding a zero, or it should also be possible with integrating by parts. And for the last one, there is obviously some power rule is going on. So if we had the antiderivative, then taking the derivative of that, there is some product rule going on and some power rule, possibly. And we start with the first one, and before we do that, I want to make a recall, and that is the derivative of the secant can be written as secant x times tangent x. And if you have a close look to this relation, so the derivative of the nth power of the secant, so the n comes in front, n times secant x to the power n minus 1, and then times the chain rule, the secant, and the derivative of the secant is secant x times tangent x, and we see that the power does not change. So this derivative, so this relation is the motivation to consider higher powers, and we see that the power stays the same, like here, and this gives the motivation to substitute secant x plus to the fourth plus 4, so the whole denominator. So u equals secant to the 4x plus 4, and this makes du 4 times secant to the 4x times tangent x dx. And now we see that this part is exactly in the numerator. So you can do this by yourself, and what we get is dx is 1 over this part du, this cancels out, so we are left with 1/4 times 1 over u du, and this integral is easy. This is 1/4 natural log of u plus a constant, of course, and then plugging in u to our solution gives 1/4 natural log secant to the 4th x plus 4. Alright? So this is the solution to the first integral. Let's tackle the second one. Like I said, I would like to add a zero, and a motivation is this 1 minus x. This gives us a hint what we add, and we add 1 minus 1 plus x, and I put some brackets, so this becomes plus x times 1 minus x to the 2020th power. Alright, so 1 plus x minus, pardon. So 1 minus x is exactly x, so we added a 0, okay? And yeah, like I said, what is my motivation for that? My motivation for that is this 1 minus x. So if we distribute that, yeah, we get integral 1 times 1 minus x to the 2020 minus 1 minus x to the 2021. Okay? So let's check, yeah, so 1 times this bracket minus 1 minus x times 1 minus x, and so this is okay so far. And now we can integrate very easy. We have to take care of the minus. So we have 1 over 2021, 1 minus x to the power 2021, and a minus, alright, from here. And then minus, and we get also a minus from that, so plus 1 over 2022, 1 minus x to the power 2022, plus some constant. Alright, so you can try this also with integration by parts. I think the method with adding a 0 is also nice, and like I said, we get the motivation from here, and this is the result to the second integral. Alright, I clean up the board and then we tackle the last one. Let's start with the third integral, and my first step is here I want to distribute the last two factors, so we get sine to the fourth, cosine to the fourth, times cosine squared minus sine squared. Alright? And now I would like to distribute again, and then we can open our eyes. So we have sine of 4, sine to the fourth times cosine to the 6 minus sine to the 6 times cosine to the fourth. Yeah, and for me this looks like the product rule, and we take care carefully. So I write this as, so let's see, I write this as sine to the fourth times cosine x times cosine x to the fifth, and then plus sine to the fifth times cosine to the fourth times minus sine. Okay, so I split it up, the cosine to the sixth to cosine times cosine to the fifth, and here I took the minus here, and then sine to the fifth is left. Alright, this is not so nice, should be here. Okay, and now if we open our eyes, we see that this part is sine to the fifth, the derivative up to a factor. The factor is 1, so this is 5 times sine to the fifth. Okay, this is the red part. This stays like it is, So let's say u prime, this is v, and then here u prime, we have here u, here is u, and this part looks like the derivative of cosine to the fifth up to some factor, and this is v prime. Okay, and let's see, v is cosine to the fifth, and this is exactly v prime, and also u sine to the fifth, and this is u prime up to a factor. This is exactly the product rule, and therefore the integral, the solution factor is 1/5 sine to the fifth times cosine to the fifth plus some constant. This is the solution to the last integral. So I hope you liked it. See you next time, and bye bye.